Hello everyone, after a very long time, my name is Akriti and I am back with one more exciting problem of Leetcode. So let's start with it. So this is a question which I am going to solve today. Let's read the question first. So the question is question number 979, distribute coins in a binary tree. Okay, so what we are given, let's start with the problem statement. So basically I am given a root of a binary tree. So first of all, if you guys are not aware of what is binary tree, so let me explain you. Binary tree is like simple tree which we are using like in my tree data structure. It is a simple tree. The only difference is this, like in binary tree, any parent node can have maximum of 2 children only, right? So it is same as all other traditional trees. Just the difference is maximum we can have 2 children in any node. So yeah, let's start with the question. So we are given a root of a binary tree with n nodes. So in my tree, I have n nodes where each node in the tree has a node value coins, right? So basically, I'm given a tree and I'm giving n nodes in a tree, and each node have a value as a data, which is a number of coins in each node, right? So overall we have n coins, and coins are distributed among different nodes in a tree. So in one move, what I can do, I can choose any two adjacent nodes. Adjacent nodes means to say I can either choose the children or the parents of any node. Only these two nodes can be adjacent to a node, right, in a tree. So I will either choose a children of a node or I will choose a parent of a node, and I can make a move of a coin. So in one move, I have to choose two adjacent node, and I can move one coin from one node to another. Okay, a move may be from parent to child or from child to parent, as I have told you. So what we have to do, we have to return a minimum number of moves required to make every node has exactly one coin. Yeah, so these are the examples. Like suppose if it is given that in my root node I have 3 coins, and other two nodes have 0 coins. So what I have to do, I have to make sure that each node have only one coin, because we have n nodes and we have n coins, right? So each node should have only one coin. This is our target basically. So I have to move the coins from one node to another and make sure that I will make the minimum number of moves, and I have to make sure at the end each node must have only one coin, right? So this is our aim. So here what we can do, we can transfer one coin from root node to left children and one coin from root node to right children. This way we will have this way I can make all the nodes have only one coin. Similarly in this problem, I can make one move from this to this. So we will have one move. Again I will move one coin from the left children to the root node. So total we make 2 moves. Now I will move one coin from root to the right children, then the total number of moves will be 3. So this was the complete overview of the question. So let me explain you with the help of example how we are going to approach the problem, right? So this is an example of a tree, most precisely binary tree. This is an example where n1, n2, n3, n4 and n5 and n6 represents the node of a tree. Total we have n nodes. Total we have 6 nodes, right? So the total number of coins will also be 6, as said in the question itself. So we have total n equals 6 number of coins, right? Now as it is given in the tree itself that the root node, like node n1 have 1 coin, node n2 has 0 coin initially, right? Node n3 has 2 coin, node n4 0 coin, n5 has 2 coins and n6 have 1 coin. So our target is like we have to make at the end that each node should have only 1 coin. So I have to make moves of coin from one node to another. So how we are going to do this? So let me explain you the approach. Now firstly understand this. Let's suppose any node, let us talk about n3, right? So let us suppose if a node has more than 1 coin, because we want only 1 coin in the end, right? But if a node has more than 1 coin, what it will do, it will simply transfer its coin to either to the parent or to its children, right? So if we are talking about N3, N3 is the leaf node, so it has no children, so simply it will transfer or it will move the extra coin to its parents, which is N2, right? So N3 will keep the one coin and it will move the remaining one coin to N2. This is what we are going to do. Now let us talk about N4. N4 has 0 coin, then it has no way of moving the extra coin to its adjacent node because it also need a coin. So it will just look at its children or parent. If somebody have extra coin or not, then it will take the coin from its parent, right? Let us suppose currently N2 has 5 coins. I'm just taking an example, right? So N4 will move the N4 will ask the N2 that if you have extra coin, then you just give me. So N2 will say, yeah, I have extra coins. Then N2 will move the extra coin from N2 to N4 and N4 will get 1 coin. In this way, we are going to approach the problem. Like if somebody have extra coin, then it will donate his coin to the adjacent node. If somebody have less coin, then it will ask his adjacent node that if you have extra coin, then he will take it from their adjacent node. So this is the main approach. Now let me tell you how we are going to approach this problem. So what we will do, we will start traversing our tree until we reach a leaf node. This is the first point, right? We will start from the root node and we will keep traversing until we reach a leaf node. So yeah, let me start with the root node, which is N1. I'm here at N1. Now I will check if N1 is a leaf node. No, this is not a leaf node. Then I will move to its left and to its right. So I will move to N2 and I will move to N5, right? Now let's first talk about the N2. So now I am at N2. I will check if N2 is a leaf node. No, N2 is not a leaf node. So again I will move to its left and to its right. So I will move to N3. Sorry, and I will move to N4. Now let's firstly talk about N3. I'm at N3. So I will check if N3 is a leaf node. Yeah, this is a leaf node, right? So if N3 is a leaf node, now I have 3 things to check. I will check if N3 has coins equal to 1. So if N3 has only 1 coin, then there is nothing much to do. We don't have to make any move. We just have to return from this node, right? So if suppose my N3 has 1 node, then we have nothing to do. We will simply return back to its parent node and I will return 0 because we made no move, right? Now suppose if my N3 has more number of coins than the required, the number of coins in the N3 is more than 1. So in this case what we have to do, now if I have more coin than the required number of coin, then definitely I will donate my coins to its parent node, right? This was something what we have discussed, right? So if N3 has more number of coin, then it will firstly make a move for make the extra number of coins times moves. Like if my N3 has 5 extra coin, then it will make 5 moves. If my N3 has 4 extra coin, it will make 4 moves this way, right? So it will increase the number of moves it made and then return those extra coins. So currently my N3 has 2 total number of coins equal to. Now N3 want only 1 coin, so it will return 1 coin and this is my moves variable for, yeah. So total number of move made was 1 and I will return 1 coin, right? Now N3 is left with only 1 coin. Now as N3 is returning 1 coin, it will reach to N2. Now N2 has 1 coin. Okay, now let's talk about N4. In N4 we have 0 coins, so N4 will ask from N2 if he can donate some coins to N4, right? So N4 will ask for coins from N2. So what we will do, simply we will increase the number of coins here 1 because we only want 1 coin, and here I will be returning minus of number of coins, because we are not donating coin, we are just taking coins from the parent, right? So here I will return -1. Here we return 1 because we had extra coins and we were donating, but here I want some coins from the parent node, right? So here I will be returning -1. And now what happened when we reach the parent node, whatever we have returned we will simply add. So initially I had 1 coin and now I am adding -1, so my total coins again will be 0, right? So now n2 has 0 coin again. Now we are at n2, right? Now n2 has 0 coins, so it also want 1 coin. So he will ask from n1 if he has some extra coins or not, right? So n2 will also add 1 coin in it. So coins in n2 will also be 1, and n2 will also return -1 because it is taking coin from the parent node. Now this -1 will add to the coins of n1, and now coins in n1 will become 0, right? So initially I'm here. Now n1 has 0 coins. Okay, now we will move to the rightmost part of the tree, right? So now n1 has 0 coins. So as we have started from the root node only, right? So we have reached the root node from the left tree. Now we will talk about the right tree. As I reach the n5, so at n5 we will check if it is a leaf node or not. So this is not a leaf node, simply I will move to its left part and to its right part, as the left part of the n5 is null. So we will simply return back without returning anything, or maybe return 0, right? And here what I will do, I will go to the right part of the n5. Now I will check if this is a leaf node. Yeah, this is a leaf node. So what I will do, I will check the number of coins this node have. So in my n6 I have only 1 coin, then I need not to do anything. I will simply return from here and 0. Right, now I am at n5. At n5 I will see I have 2 coins, I have extra coins, so simply I will make this coin equal 1, and extra coin I will return back. So I am returning with 1 coin, so here I will add 1 coin. So this was the complete procedure which we are going to do. Yeah, while returning or making moves, we also have to add the moves in my move variable, which I have not done here. You will make sure to do this, right? So like here I was returning 1, so one move I have made. Here I was returning -1, but actually the move we have made was 1 only, right? Move is not negative. So here also 1. Now here I am returning -1, so one more move will be there, the 3 move. Now from here I am returning nothing. Here I am returning 1. So this is the 1 move. So total number of maybe 4 moves or something. I'm not sure of. Yeah, but we have to count the move also while returning. So this is the complete procedure which I am going to do. Now let us code it to make the better understanding of the question. So let's make an function which will be counting my moves, right? So I will take root as an argument and nothing else. So what I have said, simply firstly let me check if it is a null or not. If root is null, then nothing we have to do, we will simply return 0, right? So now I will check if I am at a leaf node or not, because if I am at a leaf node only, then I will be making moves or doing something, right? So if I am at a leaf node, like the root child or the left child and the right child is null, then this is a leaf node. So what I will do, I will increase. I will also take a variable name count. I'm taking this by reference because I will make changes in this variable only, right? So if I'm at a leaf node, so I will increase my count by the number of extra coins we have, or the absolute difference of a total number of coins we have in a node by 1. So this way, right? Like suppose if I have 3 coins, then extra coins I have is 2. Or even if I have 0 coins, then extra coins I need is 1. So I just need to have a difference in order to count the move. Okay, let me name it move. So I will simply add my number of moves, which I have said we have not done there, right? And then I will return. See what I will return. I will return 1 minus. Um, I will return. Like suppose if I have 3 coins, then I should return positive, yeah. So I will return my roots value minus 1, because I have to take only 1 coin, and the extra I have to return. Like suppose in this case, if we have less than 1 coin, then it will return the negative value. Now after doing this, if after doing this, what I have to do, um, I have to add all my root value will be. Now after returning, what we were doing, we were adding the returning part in my roots value, right? So I will add the left returning part, and the right returning part is my in my root value. So I will simply add root left, sorry, plus returning value of the right subtree. This way I have added. So over here I have add root value with the right and right. Okay. And now I will increase my count with the extra value. Um, right, root value minus 1. Basically here we are figuring out what I have to return from my root, which I am currently at. So I will increase my count by this value, and I will return root value minus 1. Yeah, so this was our complete code. I hope you understand this. Now let me call my function. So simply I will pass, let me make a moves variable here. Yeah. And I'll return my moves. So this will give us the minimum number of moves which I will need for my for the all nodes of a tree to be equal to 1. Okay. So let me run it first. Then we will check if it is working or not. Sorry, I should move. Yeah, so I guess it is working fine. Yeah, it works. So this was a complete solution of the question. If you didn't get it, let me just summarize the whole process, what we had done. So initially what we are doing, we are just starting with the root node. We are checking if a root node is null or not. So if my root node itself is a null, then nothing I have to do. I will simply return 0, right? Now I will check if my current node is a leaf node or not. So if my node is a leaf node, then I will have to figure out like what we have to return from our node, right? So if my node has a value more than 1, then I will return the extra coins, right? If I have extra coins, then I will be returning this. Now if my node has a value less than 1, then I will have to take more coins from the parent node. So I will return a minus value, kind of negative value, because I'm taking coins. If I'm returning a positive value, means I'm donating some coins, right? So in this way, now while returning, while taking any coin or while donating any coin, you will just make a one move, right? So I will here simply add the absolute of the difference of the coins value minus 1, because I have to count the number of moves only. So here I'm adding an absolute value, and hence I will return the extra coin which I have. It may be a negative or a positive value according to the number of coins the node have, right? Now, after returning from the leaf node, I will get back to the original node which I from which I came, right? So when I will be back at my node, I will just collect the number of coins which I get from the left subtree and the right subtree, and simply I will add all these coins in my root value. So here I'm adding, because either if I'm donating or taking the coins, I will have to add or manage all these coins. Now I will again make the number of moves possible after adding my coins. Now, like suppose if I am at a particular node and I have got the values, returning values from my left subtree and the right subtree, and I have added all these values in the root node. So after adding, suppose my root has again two coins, right? So I will have to figure out again, like if I have extra number of coins, less number of coins, or they are equal to 1, I will figure out this. I will make the number of moves which requires, and then I will return that particular value, and after returning I am done. So we are just counting the moves in this moves variable, and we are returning only the extra coins which we have. So I will return the moves variable as my answer at last, because this is the final answer, like the minimum number of moves which we have made. So yeah, this was all about the question. I hope you guys understand this question. So this was my first video after a very long time. So yeah, please make sure if you don't understand the question, just ask any doubt in the comment section. I will solve it out there. Okay. So have a great day. Bye bye.